Ladies and gentlemen, now's the fun part, at least for me. Fractions as exponents. We kind of talked about it before, and maybe I'll have to redo that at some point and really talk about what it means. But or that'll be the second video to this one. A little extra in depth behind the scenes. But we've got two different problems in front of us that our brain, when we first look at them, at least when I first looked at them, like, oh, we can solve something like that? Are you kidding me? What? Like, there's a fraction there. We hate fractions. But here's going to be an example of how fractions actually tell us a lot. So when we're talking about a fraction, you've got a base, or sorry, fraction as an exponent. You've got an exponent, and then you've got the, oh my goodness, the exponent. Technically, the whole 3/4 is the exponent. That's why my mind is pausing. It's like I'm trying to combine language here. But we have the exponent, and then we have the root. There we go. I'll just call it that. Here's what I mean. In problem A, our base is 16. Our exponent is 3, and our root is 4. Now, if I was to take the base and any one of these two by itself, base 16 with an exponent of 3 looks like this. So this is base 16 exponent 3. If I was to take the root, that would be 16 to the 4th root. So base 16 root here is 4. Now here's the funny thing, and what I'm about to say is always true. When I write it as 16 and 3/4, what I'm saying is this is my exponent to the base, and this is the root of the base and exponent. In other words, I need to rewrite it as 16 to the 3rd, or the 4th root of 16 to the 3rd. So where did I write it? So this right here, 16 and 3/4, and this 16 and 3/4 here is the same as saying 16, or the 4th root of 16 to the 3rd. Now I can process that. 16, or the 4th root of 16 itself, if I were to solve this, is 2. So I can actually take this 2 here and substitute it in for this 16 here and drop the 4th root and just say, oh, 2 cubed is now my problem that I'm solving. And 2 cubed is 2 times 2 times 2, which is 8. So that's my answer. So really what we're saying is 16 to the 3/4 is 8. Now, if we look at the other problem, 27 and 4/3, I'm going to take the same idea that now I'm going to skip, and I'm just using the idea of everything here to just write it. Where did I write it? Just go ahead and skip to this. So actually I'm using all of this. Okay. The same ideas, sorry. And I had to remember where I wrote stuff. So we get 27, the cube root of 27 to the 4th. And that's because we had 27 to the 4/3. So this is my exponent. This is my root. This is my root. And this is my exponent. Sorry, I got distracted. I had a message in the middle there. Hopefully you don't see it on screen. I don't know. I got to really recap this stuff. Anyway, so here we can sit here and know that the root of 27 from earlier examples, and because I've done it enough, I know what it is. So the cube root of 27 is 3. So I can replace the cube root part with 3. And so I get 3 to the 4th. And 3 to the 4th is the same as 9. Or 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. So 27 to the 4/3 is 81.